So one of the things, I forgot to tell you, and is that if you are using Windows, then there is one file, Docker file for Windows. So generally, as we discussed, there is, there's a window puts its own, characters, and we want to convert to Unix characters. And if you want to use the same, commands to start up and everything, here you should use this as a reference. So we install, DOS to Unix. We need to install there. And once you install DOS to Unix, then we run this DOS to Unix mvnw, because apparently this mvnw file is the one where Windows was putting its, end of line character or something. So if we run DOS to Unix on this, and then we follow our usual, run this in offline mode, and then we run our Spring Boot application like this. So let's try it out. If it doesn't work, let me know, then we'll discuss. So now we'll go back to the pods. So last time we had created a pod, and we had gone through this diagram earlier also. So I will go through the diagram once again, just to refresh and to give you a complete picture what happens after you create the image, and from that image, how that Kubernetes creates the image. Kubernetes creates the pod. So you create the image using Docker. So this is a command. So you're using Docker build, you sort of create an image, and using Docker push. So this Docker build will create the image on your local Docker push, and you can issue this command, or sometimes, if your automated process CI/CD is doing, that can issue, that can also issue that command. But for our testing, we only will be doing all of this. And you have done this already. So Docker push will push the image on the local from the local disk into the Docker image repository, Docker repo. So this image will go here. Then so this image is in the Docker now. So assume that you want to run this image from Docker, from the Docker repo or image repo. So you can run this using kubectl, YAML, or command, or even API. And we have seen the YAML file of type pod, where we create the image, where we run the image. So either using YAML file or using command, you run this, using kubectl, you run the image. So what happens during that is, when you use kubectl, you have given all the thing, image name and everything else, and kubectl takes it. It invokes the REST API server of Kubernetes. Now we are in Kubernetes cluster. You see big rectangle is Kubernetes cluster. In the Kubernetes cluster, inside master node, which is control plane. Inside control plane, REST API gets invoked by kubectl. Then based upon whatever definition you have given, pod is created, and it's scheduled on the worker nodes. So that scheduler takes care of it. So how it schedules on the worker node? The control plane node, which is the master node, calls kubelet on whatever scheduler tells, these are the worker nodes or which this pod should be scheduled. For those worker nodes, kubelet is invoked. There is a runtime environment. In our case, it's Docker. So kubelet has Docker to run the image. Docker will go to the image repository. It need not be Docker. It can be this repository need not contain Docker image. It can contain any image. So, but we are dealing with Docker image. So this will go to that repository, look for this Docker image, gets a Docker image, and deploys it, and then image start running, right? Because this is a Docker image, Dockers can pull it from here and then deploy it. So and it starts, as I said, right, pull from image and sets up the pod, and that's it. So this is the total workflow. Now your pod has a container which has the this container in the pod is Docker container, which has this image running, which you have mentioned. Now, what is pod? We'll go a little bit into details into the pod. So pod is a group of one or more related containers. So you saw, how you can create more than one containers inside a pod, because containers is a plural. So you can add as many containers as you want in the pod. They always run together on the same worker node. So if you specify more than one container inside the pod, they will always run the same worker node as part of the same pod. And they run in the same Linux workspace. They have their own IP address, host name, processes, everything is same. So now service we will discuss later, but just to give you an example, let's say you have one pod 1 has 2 containers running, pod 2 has another 2 containers running, and see A, B, C, D, and like this. Now you want to access, for example, some container. Then what happens is you invoke a service, which we'll discuss later, and each port has its own IP address. So you remember that each port has its own IP address. So now this, when you are accessing container, service X provided by container C. When you're accessing a service, you don't access container directly, you access a service. And this service is provided by container C, for example. And let's say container B is trying to invoke that service. So container B will hit the service object, which we will create in some further session. And that service session identifies, okay, the service which is being asked is in container C. And then this points to that port, and then within the port, the call goes to that container. And it's a sort of load balancer type of thing. There's a separate load balancer also, but because containers in 2 different locations, so it might route these calls according to the load or something. And we will discuss service in much details later. And now if you want to list the ports, this command you will be using quite frequently, kubectl get ports, or short abbreviation of this is kubectl get PO. If you want to see details of the ports, you see kubectl describe port. Now, why do we need ports? So often a set of containers need to be grouped together, as they might need to share files. Let's say some system is writing to the log files, or some system is writing to some file, other system has to read from the same file, something like this. Or you might need to share files for whatever other reasons also. Maybe your log file where you're writing is a NFS or something. So one is writing, another is trying to read and forward it to Splunk or something. That's another reason. So there could be various reasons. Or another reason could be that so you are writing, it's mostly files, or there is you have some application which needs for performance reasons. I don't know, you want to have some reference database mounted on this on the same port, so that your application layer can read it. So that's another reason you might want to have that database and the port in the same container. Depending upon your business logic, there might be multiple reasons. And so a set of containers will group together for whatever reason I mentioned, or they connect with each other, or RPC, remote procedure call. So because of these 2 main reasons, grouping of 2 containers might be needed. When I say grouping of 2 containers should be inside one pod itself, because IP address it is a pod. So these 2 containers can talk to each other properly. So because they share the same network and same Linux space, which I mentioned, have the same host name. A container can communicate with that container in the same port through localhost, right? So you don't have to get the port IP address. It's 2 containers on the same port, they can communicate through localhost. Now you want to see the container logs. So if you want to see port logs, you can give kubectl logs port name. But if you want to see the container logs, you can give the container ID. How do you get container ID? You have, and we'll see example of this. You have described the port, so kubectl describe code. It will give you the information, all the information, including containers inside the port. let's run some of these commands, and we'll see. So I have run few of these, but I will start from here. So I want to get port, for example, kubectl get ports. So one port is already running, so I will not restart it. So I would say kubectl describe port. Kubectl describe. I can say ports and give this name, or I can say port slash this also would work. So you can see a lot of information about this. It tells when it started and everything. We'll talk about load selector also, and the commands which it used. Run this is the container ID. So I was telling you, right? You can get the container. This is the container ID inside the port, one container only. This is the image container is using. This is the image ID. I have not given any port or something, so it's not showing. And this is the IP address of the port. We'll discuss the labels also. There are some ports can have labels. which are key value pair. We will discuss it. So it shows those. This shows the node name and the node IP address over which this pod is deployed. And this is the name of the pod, and namespace also we'll discuss later. So you can get this information by using pod describe. Now you want to see the logs of the pod. So you can say, let's see the pod name again. So kubectl logs, then pod slash, and this. So this will show you the logs if you want to see the what happened inside the pod something. To see the container of the to see the logs of the container, I will leave it to you. You go and do that as a homework. So if you want to see the container logs, issue this command. Pod network. And now that if pods wants to communicate with each other, so on one node there can be multiple pods. So this is one pod inside node A, and this is another pod, and these are the IP addresses. Each pod has two containers, container 1, container 2, and this is the IP address of each pod. So they can directly access using the because they are part of Kubernetes cluster, they can directly access each other using IP address. No need for NAT. So when you access, so NAT is, what is NAT? So NAT was network address translation. It generally involves rewriting the source or destination address IP packets as they pass through a router or firewall. And you can read more details about this here. But in this case, there is no need for that. It just directly IP invocation would work. We already discussed this pods create. So you create the pod via REST endpoint by passing YAML or JSON. You can, that's one way. Other way could be that, you don't have YAML or JSON. You directly invoke command line, which are, kubectl image command, kubectl run image command, where you can pass the parameters. And this was the assignment also. So that's another way. Third way is you can directly invoke the REST endpoints. The REST endpoints payload and everything is properly documented in Kubernetes documentation, and we'll discuss that also in some further session. So now kubectl explain pods. So let's run the explain command also and see what happens. So I will again get a pod, kubectl pod. I keep forgetting the name. So for that name, I keep using this command. This is the name. So kubectl explain. Sorry. I didn't this name honestly for this. So what I want from explain pods is that what is the version it is using for type pod and the description. So this we already saw description, and the API version. So what this API version is and details of API version, kind of course is pod. So it explains about this metadata, spec, status. So I want to see, what are the, things inside a pod, what are the properties of a pod. So I can use explain pods and I can see at high level, this is what it is. There are a lot many things go inside the spec. You can go and read, I think, inside this, what are the specs and all those things. And we'll have a lot of examples too, for various values inside each of these. If you want to see only the specific version, so you can say kubectl explain pod.api version. So let's see that. kubectl explain version. So it will tell you only about the API version. If you want to see spec, so you can see. So this is a spec, whatever is inside spec. See, earlier we saw when you say explain pod, it just gives spec. But if you want to see what is inside the spec in the YAML file, these are the properties you can give inside the spec, and many of these will use. Right? We will not use all of it, but many of these we will use. Correct? So this is the spec. This is inside the spec. So I will again reiterate. So if you see only pod, it will tell you that this is the spec and just give you 2-3 liners of spec. Now, if you want to see what is inside the spec, what all you can give inside the spec key. So these are the things you can give inside the spec key. Volumes for volume mount, some service account. So there will be nodes restart policy, node selector will also be there, priority is also there, node name, and all those things. So this is what all you can give. Now, so what we will do is, as part of this exercise, we'll always, most of the time, almost all the time, we'll create pod using YAML file, and we have YAML file for each type of pod. When we discuss different topics, for Kubernetes, we'll have YAML file for each of these. Now, if you want to see how we have created our YAML file and given to the Kubernetes, and Kubernetes created a pod. Now, if you want to see how the complete description of the YAML which Kubernetes might have used, it might have done some things of its own after getting our YAML. So I can we can see this. We can use this command kubectl get pod, the pod name, and then -o YAML. So let's see that. So this is our pod. So kubectl get pod, then -o. So this is what this is the YAML for this pod produced by Kubernetes. So you can see this, and whatever value you have given, for sure those values will be there. But it adds some of its own also when it got created. This we had given, and this I added was a UID. This added by default. This commands we had given. This we had given, but then this they had, it added itself. So some things it adds. Sometimes we might need to refer some of these properties. So we can use this command. Container status is, it tells this the container, it's ready. There's no restart on this container. It's already started. State is running. It started at this time and so on. Or IP address is this and all those things. Now coming to pod dashboards. Generally, you can look at the logs. We saw that you can look at the logs. We say kubectl logs, then pod / I forgot to pod / here, pod / and give the pod name. You can see the log, and we saw that just now. You can look at the dashboards also. Kubernetes, these are Kubernetes dashboard. These are not pod dashboard. These are Kubernetes dashboard. So if you are using Docker desktop, then on the Docker desktop icon at the once you click on Docker desktop icon, it will show an option of dashboard also. So you can select that option and it will show you something like this. But if you are using Minikube, then you can start the dashboard using Minikube dashboard. This is what I have done. So I said Minikube dashboard. So it started the dashboard for me. And then this is the dashboard. This is a dashboard. So you can see all of this. Like I have pods running here, and all of this will cover cron, daemon, deployment, job will cover in session. So this is a pod which is getting deployed. I can click on this pod. It will show me a lot of information about this pod. Cluster, roles, namespaces, nodes. Only one node will be running here, which is Minikube, because it's my local machine. If you want to see details of this, you can see all of this, about this node and everything. If you are on real cluster, it will show set of nodes, and you can see details of this. So you can, look at the Kubernetes node for all such things. When we discuss each of the section, when we discuss cron job section, for example, and we create cron job, that will start appearing here. Right. So so far we have discussed only pods. Okay, that's about the dashboard. Moving on, you can create a pod from the command line without YAML. We discussed that. You can run kubectl run -help for details. Some two examples I have given. If you want to run Nginx image, you could very well say kubectl run Nginx image Nginx, and that would have done the trick, because Nginx image has its own properties and everything. If you want to override some of the things, right? Because when you give to Kubernetes, we discussed that you could create your own YAML and everything. Or if you run this from this command, we are not creating any YAML. We are telling Kubernetes to run this image. Then Kubernetes will create a YAML, and in that YAML, which Kubernetes has created as per this command, we have not created. If you want to override some things, then you can override few things. Like you can override the API version, you can give some spec or something, and you can customize using command line also. Another example is we ran our command. So kubectl run, give this our pod name. This can be an arbitrary name using this image. An image pull policy, as I said, never pull it from the repo, because it's always on my local. It means that I always take it from local. And this is a command I want to give. And once pod has started, then the container inside the pod should have this command: user bin tail -f, and then this is syntax -f, 2 hyphens and space and -f dev null. Basically, if I don't give this, then if I start this, then it will start the container, start the pod, then it has nothing to do. It will automatically try to terminate it. So to keep it busy, I give this command. And then that's another way to start this. Now we will discuss the service subject or something. But if I want to access the pod from outside without getting service object or something, for time being, we can use port forwarding. And how do you use port forwarding? So this is this address. Generally use it for debugging purposes. And this is the syntax kubectl port forward and the pod name. And this is your local host. This is your host over which your pod is deployed, the node over which pod is running. And this is the port on the pod. And if you make any request on this port on the node over which pod is running, then that request will be redirected to port 8080 on this port. Okay, so we'll see an example. I think I had already started something here. So I had given this example. Let me terminate this, or let it be there. So I've given this kubectl port forward 8888 on my local and 8080 on this pod. And let's see if this pod is running or not. Kubectl get port. So this pod is running, and this is the pod I have given here. And remember, we had on this pod, we have exposed the service on port 8080, the Spring Boot service which you deployed inside the container of this pod. So if I don't have this running, then let's see when this is running. If I do wget, let me remove, I already got it. So there's a file tips, I got it. So if I say wget localhost, so remember I'm giving localhost, I'm not giving the pod IP address or something. So on that localhost, I'm saying 8888. This is on my local machine, which is Mac in my case. I'm giving localhost 8888 and then /tips. And then I do this. Okay, looks like, oh, because I restarted the pod, sorry. So once I restart, I have to do this also. So let's do this. Run this kubectl for port forward command again. And then do this. So now I got this, right? So when I say this has come from the pod. Now, and it shows that, I have given this localhost 8848/tips, and I have configured that, port, on the localhost on this command on this request on this port should be routed to this port on this port, and it did that. So it says handling connection for 888 from, which means on my local machine Mac, and then this forwarding it is forwarding by default to 8080, correct? So, and this is the request I got from the container. So this is one way if you want to quickly debug or quickly test something, you can use this port forwarding. Moving on. Now, this is the last topic we'll discuss for today. You can organize pod with labels. Now, labels as such are just key value pair attached to a resource like a pod. Labels do not have any impact on the functionality of the pod. How pod starts, how pod runs, why pod fails. Labels have no impact on that. So that way you can consider labels as some sort of metadata for these pods. Now, why do we need this? You need this, and these are heavily used. Let's say you have, you want to get, when generally there's one Kubernetes cluster in a company. One Kubernetes cluster for dev, one Kubernetes cluster, let's say, forget dev, but there's one Kubernetes cluster where various teams use that cluster. Now, each team wants to have their own, application deployed on the cluster. And if I say, let's say there are, in a reasonable size company, there are around 1,000 to 2,000 applications, and those many pods will be created. Each application might be getting more than one pod also. So when I say kubectl get pods, you might get thousands of pods, and every time you have to look for your pod and do something. So that way we can use label, and it helps in categorizing the pods into subsets. So one team can use some label, other team can use some other label, or within one team itself, you can use one label for dev, we can use one label for QA, like same code when it goes to dev and it creates the pods in dev, and you want to deal with this, so you can label those pods with dev or something. So, so it basically helps you in dealing with the pods in a better way. So we use label selectors, to get the pods belonging to certain labels. And when I say, here I'm saying pods, but it could be any resource, and other resource other than the pod will be covering as part of this, subsequent sessions. Now we have taken a hypothetical example, and we'll see how to, handle that. So let's say you own a company, and in that company there are three, organizations, and each organization created their one microservice. So there is one sales service, there's an order management service, and there's HR service. So once they have this microservice or apps, right? So whether these are apps or microservice or whatever, the idea is that these need to be deployed on Kubernetes cluster. Now each of these app or service need to go through these environments: dev for dev testing, QA for QA testing, canary. Canary is the environment which you use generally for, for the when you're doing a limited release. You don't want to release to all the people, but you want to release to certain people to test it out. So that's where you use canary and prod. So same application will be deployed on all the environments, because it would be going through dev, QA, canary, and prod testing. So, but in reality, there will be thousands of services in any org. We have taken example of few services to explain the concept better. So now, the one question about port forwarding is that, can port forwarding be done in detached mode also? Yes, port forwarding can be done in detached mode as well. As long as pod is running, you can do port forwarding. Coming back to this, so this is a diagram. Let's say I want to assign two labels: app name and release environment. So app name represents this, release environment represents this. So how it look like? So for release environment dev, you have app sales, you have app order management, you have app HR. So so sales dev pod, how will it look like? Sales dev pod will have labels: app name is equal to sales service, which is this, release environment equal to dev, and so same sales in the QA. This app name is sales service, release environment is equal to QA, and so on. Canary and pod app name will remain same. Similarly, for order management app, it will be there in dev, QA, canary, and pod. So labels will look like this. App name in all of these environments will represent the same name, but the release environment will be different for each of these. Same with HR and something. Right. So this is how for three applications. Here I have given only three applications. I want to represent, I want to identify pods and the applications. I want to identify pods based on the application and the release environment. So what we'll do is, I'll go through these slides, then I will run the example also. So I have a YAML file. This YAML file creates a pod with this image, and it assigns some label: app name and release date, and everything else, we have discussed that. So then once I create this pod, then I can see the labels. I have to assign, I have to add extra parameter -f show labels. So these labels, once I do this show labels, it will show me the pod along with the labels. So these are two labels this pod has, and these are the two labels I had given here: app name sales, release environment dev, right? So this label get created, a pod with the labels get created. If I want to see the pods with selected labels, so I can say the pod, the pod can have thousands of labels or hundreds of labels. I don't know. Generally, we don't have. Generally, you have 10, 12 labels, possibly max. But let's say I want to select pod with, and I want to select pod along with certain label which I'm interested in. So you can say kubectl get pod and use -L option. And you can say these labels, it represents labels that show me pods along with these labels. So I'm selecting app name and release environment. So it shows me app name label and release environment label along with the other information of the pod. I can add or modify labels. So right now it has only app name and release environment label. I want to add other labels I created by a CI/CD. Then I say show labels. It shows me all the labels together: sales, created by, and release environment. If I want to modify a label, let's say for whatever reason I by mistake I gave the release environment as dev, it should be QA. So first of all, let's see, this is the pod name. Then I say kubectl label. See here I'm adding label. And pod, the pod name. Then I say release environment equal to QA and overwrite. So I use the overwrite option. So it will override the release environment from dev to QA. And this is what, when I say show labels again, so it says everything same. Release environment label has been changed from dev to QA. If I want to remove some label, so I can say same thing, kubectl label pods. I can give PO also, the pod name created, and I say hyphen here, a minus sign or hyphen. So whatever created I have done here, created by, I could have said created by, it will remove it from here. Okay. So let's see these commands in action, and then we'll discuss further topics on the label only. So this is my YAML file. It exists in the GitHub. So let's see that. So cat pods with the labels. So you see this. This is the label I'm giving. So let's delete existing pod, for example, just so as to not cause confusion. I'm giving the same name everywhere. So I'll delete the existing pod. So kubectl delete pod. Pod name is same everywhere, so I can copy this. Okay, kubectl spelling was wrong. CTL. So pod got deleted. So when I say kubectl get pod, there's nothing. Now I say kubectl create -f and give this YAML file. So I can say kubectl get pod. It shows me this pod. So I want to see the labels also. So kubectl get pod pods PO -f show labels. So it shows me these labels. These are same labels which I created here. Now let's go the another one. I want to select only the few labels. So using -l. So kubectl get pod -l. Let's say I want only app name. Here I have given both, but I want only app name, for example. So it gives me a pod with that app name. If I want both, then say release. Hope spelling is correct. Spelling was not correct. Let me copy. Release env. Sorry, release env. So it gives me okay. So it gives me this these labels. Now what I wanted to do was next I wanted to add my own label at runtime. So let's go the previous command, kubectl label, and then you see PO and the image name and the new label. Then the new label, I remove this and I say created by equal to, I say automation. AUTO init. I can give any name, doesn't matter, right? Oh, sorry, forgot to give the pod name. Java labeled. So now I say kubectl get pods labels. So it shows me that another label got added, created by automation. What next thing I want to do? So this I did. I wanted to overwrite options for release environment. I will change it there from QA. So kubectl label PO, kubectl label PO. I'll copy paste this PO only. This pod, where did that go? Then what I want was release this to QA. Then the overwrite option I have to use overwrite. So now I see the again. So it became from dev to QA. So that's about label. And if I want to remove some label, then same thing, kubectl label pod. Then I say release env, or I will release what I have added. Created by hyphen. I see show labels. Now created by is gone. So this is how I can remove the label also using the command line. And whatever you can do using command line, you can do using API, YAML, and everything. So, so that's about label. Now, selecting ports via label selector. Now it is, see, we saw how you can select the labels, how you can see the labels of the port. But if I want to, and we saw one example where you can see ports belonging to that label. But labels, there's a label selector, basically tells you can select the ports based on the label, and it provides, good amount of extra functionality. And we'll see that now. So what is label selector? It is basically filter ports based upon the key, based upon key or key and value, based upon the only key, based upon key and value together. There are multiple criteria. And what are those criteria? The port has or does not has label with a key. Like when I say label and the value, what do you mean by that? This app name is label, for example, and sales is value. Release environment is label and QA is value, right? This is what label and value means. So you can select port which has or does not has label with a key, which has label with a certain key and a value, which has label with certain key, but value is not equal to the one specified. And so I create this port I just created. I will create another port also. And the difference between this and another port is that here you have app name sales and dev, and you have app name HR and QA. The app name is HR and release environment is QA. Correct? Here app name is sales and release environment what is dev. So let's create that as well. And what we'll do, let's go through this first and then we'll see the example. Then you see the labels of both of this. For one, you see sales, app name sales, release environment dev. Other, you see app name HR and release environment QA. Then I want to see the ports with certain labels. I can say get port -small l now. App name equal to HR I can specify. So it will not show me the sales and result, it will show me for HR only. Then I can see, both app name equal to HR and release environment equal to QA. Then again, it will show me the result. The idea here is to show you, you can have the multiple labels while selecting the ports based on certain labels. One example I have given is that you can select the port which doesn't have the label app name, because our both ports have a label app name, so it will not return any result. But this is how you should, not in single quote. So any port which doesn't have the label app name will show here. So let's see this example, then we'll go through these other options available. So the example for this is, so let's create another port. So cat port with ports with labels, I think. Ports with labels, and _2 YAML. So you see here the app name is HR and QA. For the previous one we had sent, the labels was app name sales, release environment dev. So let's create this. So we'll do kubectl create -f. This support got created. So now you can say kubectl get port. I should say show labels. So you see, first port has app name sales, region QA. Second has app name HR and region QA. We changed the region, it was dev and we changed it to QA for first port also. Now what I want to do is, so this is we have done. Now kubectl get ports -l. So kubectl get ports -l and say app name equal to HR and show labels. So it shows me only the port which has app name HR, and I can give both of these as well. To app name HR and this. Sorry. Okay, both and maybe a space also. Sorry, my mistake. So I get this. Now this we did. This also we did. So now what I want to do was, if I want to select the port which doesn't have label, so what I'm going to do now is modify this and remove this and say not and say this. So we will not have any port which doesn't have app name, right? So it returns nothing. Other options available are, you can say label name, give me the ports where label name, certain label name doesn't have this value. So it will return that. Or you can label names have, in like, if you know SQL, you fire SQL query, say where, zip code in first zip code, second zip code, third zip code, you could use that also here. Or you can say not in, like it will return the ports where the value of this label is one of these. If you want other reverse, give me the ports where this label doesn't have any of these values, then you use not in. So these are the options which are available. We'll come to node selector next time. So I'll pause it here.